Assalamu alaikum friends. Today we have brought to you a complete guide of installing the solar power system at your home. After watching this video, we will expect from you the ability, the technique, a complete learning of installing the system on your own or with the help of your normal local electrician. It is very important to understand all the basics before you proceed to buying the stuffs or before proceeding to taking the services, even services from the vendors or installers of solar systems. Sometimes they use their own techniques, they use their own styles, and you don't even know what they're actually doing or what systems or settings they're performing or what systems they're installing. So it is better to first understand, learn the basics, and then decide whether to do the work on your own or take the services from experts, and at the same time understanding or watching them or monitoring them as to what they're doing and knowing of what they're actually doing. Solar system has different things. Let's begin. You will be requiring the panels, solar panels of different capacities, the inverter, wirings, DC connectors, AC connectors, DC breakers, AC breakers, MC4 connectors, and different stuffs. So what will happen and how this works? Let's begin with an example. In the upcoming video, we'll be showing you the video in this, a demonstration of the installation of solar system after clearing some basics of yours. You can start with series and parallel connection. Let's say you install an inverter of 6 kilowatt. 6 kilowatt is actually 6000 watts, and an iron. A normal home iron consumes about 1000 watts. So 6000 watts mean that it is 6 kW, and this figure is equivalent to 6 irons. Now, if you want to install a setup of 6000 watts or 6 kilowatts, in this system, in this demonstration, we have installed about 9 solar panels, each having the capacity of 445 watts. So, when you multiply 445 watts with 9, you will get the figure of 4005 watts. The solar inverter has the capacity of 6000 watts, and at the moment in this demonstration what we are showing you, we have so far installed 4000 watts. Now this will not give you produce exact 4000 watts. There is always the deduction of about 25 to 30%. So after deducting 25 to 30%, you can expect about 2500 to 3000 watts of production at your home. And this is in the summers. Let's say if summer begins in your city in the month of March and it ends in the month of October, so you can have this production between these months about 2500 watts to 3000 watts. So, how to set up the panels? In setting up the panels, there are two options with you. One is series connection, another is parallel connection. In series connection, there is an option in the inverter to provide voltage. Actually, panels provide voltage to the inverter. They consume energy from the sun and they provide voltage to the inverter. Each inverter has the capacity, the range of voltage. In this example, we have used Fronos 6 kilowatt inverter in Infineon, and it has the range of accepting 120 volts to maximum 500 volts. But if you install panels that consume that provide the power of about 120 to 150 voltage, it will not produce sufficient energy. Now we have to target the installation of 2500 watts to 3000 watts. So in this way we will have to install the number of panels that should give us 2500 watts to 3000 watts. So for this we have to we have to prepare the connection in series. What happens in series is that each panel is connected to another panel. One panel is connected to another panel in a chain, and what it does, it multiplies, it adds the voltage. The more the series you make, the more the voltage is added. What happens, the first panels, let's say you have 9 panels of 445 watts each, as you can see in the video. The first panel's positive wire, this is the wire, just under it, just under the panel, you will have, under each panel you'll have two wires, one positive, another negative. In series connection, the positive is left just as it is, that is not connected to anything, and the negative of the first panel is connected to the positive of the second panel. In this way, the series goes on until the ninth panel. In this way, the negative of the ninth panel is left as it is. So after making all connections of series, what you will have is the positive of first panel and the negative of the last panel, that is the ninth panel in this example which we are demonstrating to you. You will take both these positives and negatives down to your inverter and connect to the inverter's positives and negatives connections or ports accordingly. What will happen in this? Each solar panel of this capacity, this is the solar panel of BTA company. Actually, this is the solar panel of Ryzen. Ryzen is world's top 10 company. It comes under top 10 solar panel companies, and it is manufactured in China. So Ryzen produces tier 1 A grade panels, and these panels produce good efficiency, good output. And if you pick up this specific example of 445 watts of Ryzen company Ryzen panels, they provide about 45 voltage. Each panel provides about 45 voltage DC voltage directly picking up from the sun. If you add them all, these 9 panels, you'll come up with 405 volts. In your inverter, there is a range of 120 to 500 volts, as we explained you a few moments ago. So, if in your inverter there is a range of 120 to 500 volts, so what you will be requiring is to trigger the voltage near 500. I mean near 450, not exactly near 500. A gap should be, a difference should be of 25 volts to 50 volts. So it is best to target about 450. And in this example, after installing 9 panels, we have attempted to target 405 volts. Now this target is expecting to produce about 2500 to 2800 watts of energy. The more the panels we add, the more the energy will be produced. Now this is called series connection. So can you do this with 18 panels, 15 panels, 12 panels? No. You can only add panels that should not cross 500 volts of your inverter's capacity, maximum capacity. So what will happen if you want to go near 6000 watts? Now these are just 4000 watts and you still have the capacity of 2000 watts. So if you add 2000 watts, you'll have more panels, and if you add these remaining more panels in series, you'll be crossing 500 volts of the capacity of your inverter. Now what should be done? In this case, what you will be doing is to add panels in parallel, like 8 panels in series and next 8 panels in series. Both the panels in series will have two positives and two negatives. Like series 1 will have one positive and one negative, and series 2 will have one positive and one negative. So in parallel connection, what happens? Voltage is not added. Voltage remains the same, but the ampere is added. So the first string, the first series, the positive of the first series is first joined with the positive of the next series, and the negative of the first series is then joined with the negative of the next series. In this way, after joining both the positives and negatives, you'll have one positive and one negative to go down to your inverter. So this is called parallel connection. I hope you got the parallel connection. So here, after understanding series and parallel connections, what you're done with is you have finally brought two wires, one positive and one negative, down to this inverter. On this inverter, you will have options. How? You will have utility. Your power supply company provides two wires to you. One has the phase that has the current, and another is the neutral, that is the black wire. The inverter takes two wires. These two wires are taken from the inverter, but before putting them to the inverter, you install a voltage protection device between these wires. What will happen with the voltage protection device is to protect your system, to your inverter, from electronic surges like voltage up and down that may happen, that can happen anytime. So this is how the system would look like. On the exact left, where there are fingers, where the fingers are touching, that is the breaker which has the two wires of your power supply, and from this breaker the two wires will then go to this box, the green box. This is the DB box, and in this DB box there is a digital voltage protection device on which you would be seeing the numbers. The wires go into the voltage protection device, and from this voltage protection device, the two wires finally go to the inverter, which is installed right next to, on the right side of this DB box. That is the green big box which is installed right after the DB box. Now inside the DB box, just next to the voltage protection device, there is a breaker of white color, and this is the DC breaker of 62 amperes. This DC breaker actually has the wires, the two wires that have come from the solar panels. These two wires coming down to the solar panels are connected to this DC connector breaker, and then from this DC breaker the two wires go to your inverter. And then next to this DC breaker there is another big size breaker which has the black pull down up down trigger. This is the breaker of 125 ampere. It is of a battery. When you install the battery, this big size breaker is needed. And how this is installed? Your inverter has the poles, negative and positive poles of your battery. You install 16 mm wire, at least 16 mm DC wire on in the inverter, in the inverter's negative and positive poles of your battery, and then these two wires go to the breaker, this breaker, and then from this breaker the two wires go to your battery. And as far as the wiring of the wire quality of your panels is concerned, the DC wire is needed for your panels. The wires, the two wires that come from the roof, from your panels down to your inverter, first to the breaker and then to the inverter, the size of this wire should be at least 10 mm in copper, and this is DC flexible wire. So we have explained you the things so far, and after this breaker of the battery breaker there is one orange breaker right on the right, exact right side on the right, that this breaker is actually to install, to provide power to your home. Now let me explain all the breakers once again. Exactly on the left, right before this DB box of green color, there is a white box, white breaker on which there are fingers. There is the hand touching, fingers touching. This is the breaker which has the power from your power supply, and then from these two breakers, this breaker, the two wires go to your voltage protection device in the DB box, the green DB box, and then from this voltage protection device two wires go into your inverter, and from your inverter the two wires go to your home, and they actually get connected. One of these wires, the positive one, gets connected to the breaker first. Just inside this green DB box, there is one orange breaker right on the exact right side. This breaker is installed, is connected in the wires that go to your home's load, to your home's devices, appliances. Before this orange breaker, there is a battery breaker, and before this breaker on the left, on the third left, there is a DC breaker of your solar wires, 10 solar wires coming down from your roof, from your solar panels, and just before this, on the first, on the left side, on the left first, this is the voltage protection device. These are the breakers of your green box, and just on top of them, on top of these breakers, there is one selector. The black one is the selector. The selector is installed to select the power source from your inverter or from your electric supply company. Let's say your inverter goes wrong, it breaks down and goes to the warranty claim. So with the help of the selector, you just switch to your power supply directly. It's actually a bypass to your power supply directly. And next to the selector is the voltmeter. It's to show how much voltage is being consumed and what voltage is coming from your devices, I mean from your solar. But it is not necessary, or it can be installed on your solar connection to understand what voltage is actually coming, but it is still not necessary because the inverters of nowadays do have a display, mobile app, Android and iOS app, so you can monitor all such things on your app. So these are the explanations of the DC breaker and DC system, breakers, wiring, and these boxes. So we have so far explained you the series connection of your panels, wattage, how much each panel uh, can produce power. There are panels coming in market of different sizes, different wattage capacity like 445, 430, 410, 530, 520. There are panels also coming from 150 watts, but you have to match them with your inverter setting. Let's say if you're installing a high power inverter of about 8 kilowatt or 10 kilowatt or 6 kilowatt, beginning from 6 kilowatts, so you would be requiring the panels of at least 450, 400 plus watts, so that they could produce enough voltage and amperage to provide to your inverter, and then your inverter would be in a situation with the ability to convert DC voltage to AC voltage. So what I explained you is being shown to you the wiring. The left two wires here you saw are the wires of your electric supply, negative and positive, and next to these left two wires, the two wires are actually going to your home's load, and this is how the connection is being made as we showed to you. Voltage protection device first, then DC breaker, then the breaker of your batteries, and then right after that the one we showed you, the orange one, and this is the gray one, is the one which is connected between your loads, the two wires coming out from your inverter and then going to your home's load, your house load. And in this box there are two silver connectors poles. These are actually of your battery, and just on the right side underneath the inverter there are two connectors coming down unconnected, the black ones. These are actually MC4 connectors, and on these MC4 connectors your solar wires are connected, and they are also connected through the MC4 connectors. MC4 connectors are actually the IP65 connectors. They are waterproof when installed properly. They are waterproof, they are shockproof, so you can install them in open sunlight, in open sky, and if there is rain, there is nothing to worry about. So these MC4 connectors are connected. You can search internet to see how they look like and how they're connected. It's easy. And what I explained a few moments ago about the installation of all the things, even selectors, DC breakers, this demonstration is actually going on, and here the example is being seen. You can see the things here being connected. all wirings and all the things, the explanation of which we provided to you a few moments ago. So this is the inverter, and on this inverter the wiring connection is going on. Now after explaining you all the things, we'll be coming to the installation of batteries. So what type of batteries are available? There are basically two main types. Different types of batteries are available, but the most commonly used batteries are the tubular batteries and the lithium batteries. These are the common batteries of these days, of nowadays, and the difference between them is the life cycle. Lithium batteries have more life. They work for about 5 to 8 years, at least 5 years, and tubular batteries need maintenance. They require water, I mean lead acid water to be poured into after the water level drops. This maintenance is required, and the life cycle is about maximum 3 to 5, is not maximum 3 to 5 years, it is minimum 2.5 years and maximum 3 to 5 years. But they're cheaper, quite cheaper, and are being used very commonly, more common than the lithium batteries, because lithium batteries are very expensive. Now as far as the power is understood, now this is the display. The display shows on the left side is 253 voltage coming down from your solar panels, and then under this is the WH watts, 870 57 887 watts are being produced. So this display was the explanation, and here what I explained, what I showed you, came up in the DB box style that you show, that you saw, that we showed to you, and the connection is being shown to you once again from the closer point, from the closer view, so that you can understand what we explained you would be like this. And you can even show this to your electrician. If your electrician does not know the installation of solar panels. Now this is the display we were explaining to you. On the left side, 386 is the voltage coming down from your solar panels, 809, and then further things is the load. On the display, the load was actually showing how much load is being consumed at your home. The display shows this. We'll show this to you once again. Right on the right side, 2.0 kW is the load, and under this 2.0 is the VDC voltage of your battery. This is not connected, so it's not being discussed right now. And on top, input is 230 input coming from your power supply. This is the voltage coming from your power supply, and how much voltage is going to your home. And this is the display of your inverter, which shows 18% is the 18% of your power. This is the lithium battery. As I explained you, the battery, let's say a lithium battery has a capacity of 100 Ah. There are inverters that actually support the voltage of battery. Some inverters work with 24 volts, some inverters support for at least 48 voltage. So in if you're installing a 48 voltage, now higher inverters, let's say that are more than 6000 watts or 6 kilowatt, they require at least 48 volts of your battery configuration. So in this way, if you're installing a battery of 48 volts and it has 100 ampere hours mentioned, so you can understand by multiplying, I mean you can understand it by multiplying 100 into 48. It will give you about 4800 watts, or let's say 5000 watts. So if your battery has 48 volts and 100 Ah, that has the capacity of 4800 volts. For watts, not volts, watts, wattage. So what I told you about an iron, a normal home iron consumes about 1000 watts. So if you use this iron of 1000 watts on your battery, uh, so your battery has the capacity of 4800 or 5000 watts. Let's pick up let's say near about or round it off to 5,000. So you can use this iron for 4.5 to 5 hours if the iron has the capacity of 1000 watts. So this is how the power capacity and power balance or power energy consumption is calculated. So this is the power of your battery, and this is how it works. And this is the display panel, which comes with usually all types of inverters of nowadays. There are inverters of different ranges, different capacities, and different features and functions, and you can search for them. And the better the inverter is, the let's say if the inverter is of the best quality, it must have following features. I mean, the features which I'll be telling you in a few moments, like the inverter of a good quality. If you are intending to install a good solar plant of about 5000 watts actually, or 6000 watts, then the inverter should have following features like Wi-Fi, pure sine wave, hybrid inverter to work with your to work with your solar, your power supply wires, and with battery, all three connected together. I mean, not together, all three connected simultaneously inside the inverter. Now this one is the MC4 connector I was explaining you, referring to about in a few moments. After all the installations, the DB box, the inverter, the wirings, all the things look like this. Now the voltage protection device. Now this is the DC breaker of your solar panels, the bigger one. Next to this was the DC breaker of your battery. This is the selector, as I explained a few moments ago, and this is how the inverter looks. Now we'll explain you some of the settings of your inverter, which come preloaded usually by default in most of the inverters nowadays. One setting is the connection or the configuration type of your solar power. Let's say there are options like SBU, USB, SUB, and MKS in your inverter. SBU is a setting which actually does the thing is to provide power to your home from your solar first, and then B comes with B means battery. It will provide power to your home from the battery then, and then utility means it will then in the end provide power to your home after solar and battery both have exhausted. This is how SBU works. Similarly, SUB is solar provides the power first, then utility provides the power, and then when they both are not available, the battery comes as a backup in the end. So you can design the strategy according to your needs and requirements, and this is how things work. There is a new feature being introduced in the market is MKS in the inverter. MKS is the technology of sharing two powers. Like if you're not intending to install the battery for some time, you can share the power of your home between your solar and power supply. Since you have already learned and understood that the inverter can take the wires of solar, your power supply, and battery all together combined. So this hybrid inverter, or usually hybrid inverters, have this kind of quality of sharing the power. So this is the benefit, the example of hybrid inverter. Now this thing which you are seeing, which is being shown to you, is something different. This is basically the changeover, and it was actually before installing the solar panel. Like the situation was like this before, and after installing the DB boxes and all protection devices, things have become very more clean and better. This was unclean, untidy, and wirings were not proper. And now this thing has been removed. And what we showed to you, like the DB box and all breakers inside the DB box and all the protection devices and breakers were installed. This is called clean installation, and what you're seeing is the changeover, the traditional old changeover, which has now been replaced. So we have explained you all the things, all the precautions, all the necessary connections, and now this power changeover is not needed at all, since all the things are coming from the inverter and DV box and all the breakers, and these are the wirings. This is the wiring connection done on your lithium battery. The lithium battery looks like this, and in the end we would be telling you the difference between lithium and tubular battery. Lithium has a better life cycle, about 3000 life cycles, and a tubular battery has about 1500 life cycles. So this is how things work, and this is the display which we are showing you once again as to how the figures, the numbers look. And we explained you all the things a few moments ago about the load, about the power coming from the roof from your in solar panels, and the power your house is consuming from the solar and from your house. Even if you're consuming the power from your power supply, this display would show that thing too. We hope you understood all the things. We hope you enjoyed listening to the demonstration, listening to the guideline of how to install the solar panel, solar system at your home, and different precautions, different DC, AC connections. There are actually two DC breakers. One is the DC breaker of your solar inverter, and the battery also uses the DC breaker, since these two uh, power sources are the direct currents, DC connections or DC configurations, so they require DC breakers. But as far as the other breakers that we showed you that were installed on your home supply, home load, and also before your utility or power supply from your utility company, just on them the AC breakers are connected. So your electrician can guide you, would guide you better when you intend to install this. Just on the left is the AC voltage breaker. Next to this is Schneider DC breaker. Just next to this was the DC battery breaker, and this is the selector. And here we hope you enjoyed watching this demonstration of the installation of solar connection, solar system at your home. Thank you so much. We hope we covered all the things. Just one or two things are left, like boost voltage, float voltage, and recommended uh, amperage of your battery charging. If your battery has 100 Ah power, then it is recommended to charge it not more than 10 amperes to increase to protect its life from deteriorating. And the boost voltage is actually the setting in your inverter is to provide power to your battery for the in the beginning for some time. Let's say your battery has drained down to 10%. It should not be recommended to drain it down to 10%. It should be drained down to maximum, I mean to minimum 20%. And if you have drained it down to below 10%, let's say, then what happens is the inverter setting, every battery, whenever you buy the battery, there comes the configuration manual of boost and floating voltage. So in your inverter you set this up according to your battery manual. Boost voltage is the boost that is provided by the inverter to your battery to charge your battery quickly in the first, and then up to certain level it does so, and then after that it provides the floating voltage. Floating voltage is the voltage that is provided by the inverter to your battery to maintain the top level of your battery percentage of your battery power. So this is how the settings of boosting and floating voltage, the settings of boosting and your floating voltage are done. And there is also a cutoff voltage that is also provided, mentioned in the manual that comes with your battery when you purchase the battery. And sometimes such figures are also mentioned on your batteries. That is also that is about the cutoff voltage. Let's say a battery of 100 Ah usually has a cutoff voltage of 44 volts. It will not go below 44. Each battery has a cell, and a battery at 54 volt. A battery at 54 voltage is usually 100% charged. Like a battery cell is 100% charged when it is 4.2 voltage. Like each battery pack has 13 cells, and when you multiply 13 cells into 4.2, you'll get 54 voltage. And when you multiply this with 3.7, you'll get 48 voltage. So at 48 voltage, your battery is usually 50% charged. This is the configuration usually of a battery pack, though the battery is of 48 volts, but it charges up to 54 volts at 100%, and its lower, the bottom percent is usually 42, 44. Below 42, or even below, or at last 40, below 40 is not recommended to go below 40. In this case, it means your battery, you have drained down to the lowest level of taking the battery to dead position. Now you can search internet or further on internet as to what these configurations mean. Like the battery cell begins with 3.7 and then it goes to 4.2 at 100%. This is the voltage of a small cell, and these small cells are connected in series, and then they make up about 24 volts, 12 volts, 24 volts, and 48 volts, depending upon the configurations, depending upon the requirements of the need of power. So this is how the battery system works, and this is how the solar system works, and what how the solar panels function. They pick up sunlight, and they are installed on exactly facing the south. They are installed towards the south, and the tilt angle is depending upon the latitude of your city. If your city's latitude is 24, or it is 34 or 33, whatever it is, you install according to the latitude of your city, and it is actually about the tilt angle of your solar, as to how much tilt you give it to, so that you get good sunlight. We hope you understood all the things, and after understanding all these things, after watching this video, we hope you would have learned the basics of the solar panel installation. Thank you so much.